let's get started because tonight's notes are a little bit meatier than the other ones. The first thing we want to talk about is array. Array is another figure that we use in geometry that is part of a line. It's kind of a combination. On one side, it's a line, and on the other side, it's a segment. So we've got an endpoint, and then it extends forever in the opposite direction, kind of like how the ray of a sun originates at the sun and then extends forever and ever until it hits the earth, for example. Rays are named with the endpoint first. That is key. Make sure you make a note of that. The the endpoint always needs to be named first when you name a ray. So whereas with a line segment, we could name either endpoint first. With a ray, it has to be the endpoint, and then you can use any other point that lies on the ray. So we could never call this ray AB, for example. It would always be BA. The symbol for array is probably exactly what you would think. It is a line on the top of the two letters with one side not having an arrow and the other side having an arrow. And we will always write the symbol for array that way, even if, for example, it was shooting off in the other direction or pointing downwards. The ray symbol always points to the right. When we put two rays together, we get an angle. So any two rays that share a common endpoint create an angle. And we have lots of different types of angles. We have acute angles, we have obtuse angles, straight angles, right angles, and we have also different ways of naming them. So the most precise way to name an angle is with 3 points. So we need the point on one of the sides of the angle, and then we follow it to its endpoint, and then we trace it back down to the point on the opposite side of the angle. So this angle right here could be called angle CAB or angle BAC. Either one is fine. The rule is that the vertex of the angle, the corner of the angle, has to be the middle point. If we only have one angle, we can actually name that angle with just one point, just the vertex. The tricky thing is when you have multiple angles at that same vertex, then you have to name it using 3 letters. And then occasionally you'll also see angles named with numbers. The number will be inside. If there's no degree measurement with the number, that's how you'll know that it's naming the angle and not giving you the measurement of that angle. Okay, and the symbol for an angle is just this kind of squished letter L. Okay, so like I said, we have different kinds of angles. And then when we pair some angles together, we get different angle pairs or angle relationships that we need to talk about. So we have adjacent angles, which refer to any angles that share a common side. So we could say that one room, for example, is adjacent to another room because it shares a common wall. It's the same concept as that. Adjacent angles just share a common side and a common vertex. A linear pair refers to adjacent angles because they share the side that form a straight line. So a linear pair is a specific type of adjacent angles that share this straight line. Vertical angles are angles that are formed from two intersecting lines, segments, or rays. So vertical angles are the angles that are opposite from each other. So for example, this angle right here is vertical to this angle over here. Or we also form these vertical angles up here and down here. One thing to note about vertical angles is that they are always congruent. So anytime you see a pair of vertical angles, you can immediately assume that they're congruent and use that to help you solve any problems. Complementary angles are any two angles whose measurements add up to equal 90 degrees. A lot of times you'll see them adjacent to one another forming a 90-degree angle, but they don't always have to be. So complementary angles don't have to be next to each other, but if their measurements add up to equal 90 degrees, then they are complementary. And finally, supplementary angles are angles that add up to equal 180 degrees. And you may remember that a straight line also equals 180 degrees. So linear pairs are always supplementary. And supplementary is just the more general term. Any two angles can be supplementary. They don't have to be a linear pair. So any two angles can be supplementary as long as they add up to equal 180 degrees. Okay, and then the final thing that we want to talk about tonight is perpendicular. This describes lines or segments that intersect exactly at right angles. So like this, we have a symbol for perpendicular. We name the perpendicular lines, and then in between we put this upside down T, and that is the symbol for perpendicular lines. So this would be read as line GH is perpendicular to line QP. Okay, so we went a little bit over. I'm sorry, we're all done.